Hello everybody, this is Mrs. Denton and welcome to your first video for Unit 3. In this video we're going to unpack and explore the distance formula. Here what we're trying to do is find the distance between 2 points. In these first 4 examples, the points are going to create either horizontal line segments or vertical line segments. Let's take a look at example 1. First things first, it says to plot these points. So this is the point 3, 1, which means 3 is the x value and 1 is the y value. So we move right 3 down the x-axis and up 1 on the y-axis to get to point A. Remember, a point is a location, so it totally makes sense that a point is on a coordinate plane. Then we need to plot the point B, which is at -4, 1. Again, -4 is the x value. Here we go left 4 and up 1 for point B. Now our job is to find the distance between A and B, and that's what this notation here is telling us. When you see 2 points without a segment bar or without a ray or without a line above them, it is asking for the distance between the 2 points. Distance between 2 points. So here we want to know, what is the distance from A to B? Well, if I start at A and highlight my path to B, I've covered 1, 2, 3, 4, 5, 6, 7 blocks. So the distance from A to B is 7. Take a moment and try example 2. So what I've gone ahead and done is plotted the points C and D. If your points are in a different location, then maybe you need to come talk to me or Coach Holter about how to plot points accurately, because that's a very important skill that you've picked up in your algebra classes along the way. Here I've got C at -5, 3 and D at 0, 3, and I'm asked to find the distance between the 2 points. So from C to D, got 1, 2, 3, 4, 5 points. So I hope you got 5. Take a moment. I'm going to pause the video and I want you to try these last two examples. Okay, for EF, the distance from E to F in example 3, I got 11 blocks. And for example 4, the distance from G to H, I got 5 blocks. If we did not get the same thing, then you need to stop where you are and come ask a question, because we really can't move forward until you understand how to plot points and find the distance of a horizontal or vertical line. In fact, the easiest way to find the distance between these points is to count. We don't need any special formula. We don't need anything geometric at all. All we really have to be able to do is plot the points and count. Now, what's going to happen, flip over with me, what's going to happen when the points are diagonal? Oh, my pen bled through. Let me get a different copy. Just going to have to go with what I've got here. Okay, so what is going to happen if the points are diagonal from each other? Well, I've got 2 different methods I think you might like. So let me share a few things here with you. First, in option 1, step 1 is going to be to plot the points, of course. So let's go ahead and do that. I've got point A at -6, so that's left 6, -4, down 4. That's an X and a Y. Then I've got K at -4, +1. So now these 2 points are diagonal from each other, so counting is not an option. I cannot count along the diagonal. So we're going to use something that you've already practiced, and we are going to turn this into a triangle. I'm going to switch colors here so I can see it better. So next, I want you to draw in a right triangle. Let me show you what I mean. Draw in a right triangle. So I'm just going to drop straight down from point K and go to the right from point J, and then my diagonal is going to create a right triangle. Okay, now I'm trying to find the distance from J to K, so I'm going to go ahead and highlight that as what I'm trying to find, but I'm going to use the triangle to help. To use the triangle, I need to count the distance on the horizontal and vertical path. So count horizontal and vertical distances. Okay, so my horizontal distance, 1, 2 blocks. Vertical distance, 1, 2, 3, 4, 5 blocks. So horizontal distance 2, vertical distance 5. And now I'm going to use the Pythagorean theorem to help solve for the diagonal, solve for the hypotenuse. So step 4, use the Pythagorean theorem. You know what that is. Good old a squared plus b squared equals c squared. We've practiced that recently with some review. And you've also done it for several years in different math classes. So this should be something you're feeling really confident about. Now, remember, very important to remember, that the c value is the hypotenuse. That's what I'm trying to find. That will be the distance from J to K. So when I go plug in these values, c is what I'm trying to find. I'll call that x, since that's what I'm trying to find. So I'm going to use the 2 as the a squared, and the 5 as the b squared. There we go. 2 in the a position, 5 in the b position. And I'm trying to solve for the distance from J to K. 2 times 2 is 4. 5 times 5 is 25. 4 plus 25 is 29. And now I need to get x by itself. And hopefully through your review practice, you know what to do here. To get rid of a square root, the inverse, to get rid of a square is a square root. They are inverses of each other. So now we know that x is the square root of 29. Square root of 29. 29 is a prime number, so I know that I can't break down any further. That is an exact answer. But I'm going to use my calculator to convert that into a decimal because that might be more practical. So on your calculator here, if you turn it on and go to the home page, we choose calculate. The square root button is on the left side. It's in blue right here. It's teeny, teeny, tiny, just beside the 4. To get it, I want to hit Control, and then I'll pick the square root button. I'm looking for the square root of 29. The square root of 29 is about 5.4 if we round to the 10th. So I'm going to write in 5.4. Square root of 29 is about, I'll use these wavy equal signs to say, is approximated to 5.4. Okay. So why don't you take a second and try this example down below using the Pythagorean theorem method. I'm going to split my workspace here because I have another method I'm going to show you, but we'll try the Pythagorean theorem method. Go ahead and plot your points and draw in your triangle. Then pause the video and check to make sure that our pictures look the same. Okay, so I've plotted L, I've plotted M, I've drawn in a right triangle here. I've counted the horizontal distance as 2, the vertical distance as 9, and I know I'm trying to find the distance from L to M, which is this highlighted diagonal. So I'm going to use my Pythagorean theorem again. 2 is going to be in the A position, 9 in the B position, and I'm looking for the hypotenuse of the triangle in the C position. 2 squared is 4. 9 squared is 81. 4 plus 81 is 85. And now I need to solve for x by removing the square on the x. The inverse of a square is a square root. So I need the square root of 85. Well, don't forget that we can find this exact square root by breaking down 85. So let's see what 85 divides into. I'm going to try dividing by 5 since it ends in a 5. So if I try to break down 85, I'll use this side space here. 85 is 5 times 17, both of which are prime numbers. So the square root of 85 cannot be simplified to anything else. It is already a simplified value. However, if I do want a decimal approximation, remember we hit Control to get the square root key, and we're looking for the square root of 85, which is approximately 9.2. Approximately 9.2. So we've got our exact value, which is the square root of 85, and our approximate value, which is about 9.2. Okay, I'm going to show you another option, which is really what the SOL wants you to use. And this option is called the distance formula. So we're going to start with plotting points, just like we did, because we always need a visual. So we're going to start with step 1, plot points. So let's go ahead and get that done. I'm using the same example that we previously used so that you can see the comparison along the way. So I've got J at -6, -4, and K at -4, +1. Okay. And instead of drawing out a right triangle, I'm going to use something called the distance formula. Okay, write this down very carefully. Distance formula is D for distance is equal to a giant square root, everything in the formula is underneath this square root, of x2 minus x1 squared plus y2 minus y1 squared. Now, if you're someone who's really great at memorizing formulas, this is such a handy formula. It's really a lot faster than using the Pythagorean theorem. These are a derivation of each other, and that's why we can use either option. Now, over here in our points, we have point number 1, I'm going to call J, and point number 2, which I'm going to call K. So point number 1, I'm going to call X1 and Y1. And point number 2, I'm going to call X2 and Y2. So now I know exactly what to plug in to these positions. So let's watch here. The distance from J to K is equal to giant square root. Probably going to write so big I'm going to come over into this box. X value number 2, which is -4 from the K, minus X value number 1, which is -6 from the J, close parentheses squared, plus, second set of parentheses, Y value number 2 from point K, which is a 1, minus Y value number 1 from point J, which is a -4, close parentheses squared. Okay, so check out that plug-in. We've got point J, which we've called X1 and Y1, -6 and -4. And then we've got point K, which we've called X2 and Y2 as -4 and 1. Everything else about the equation is built into the formula. The giant square root, these minuses inside the parentheses, the squares, the plus, all of that's built into the formula. The numbers are what come from the point. And now we just do the math. Now you can do the math step by step using good old PEMDAS. That's of course what your math teacher loves to do. I'm going to walk through that, and then I'm going to show you how to load it into your calculator in one giant swoop. So using PEMDAS, P in PEMDAS stands for parentheses, so we do this work inside the parentheses first. So I've got -4 minus -6, a double negative. It's truly a positive. So -4 plus 6 is 2. I've got another double negative, which I'm going to make a plus a positive. So I've got 1 plus 4 is 5. Next, the E in PEMDAS stands for exponent. So I've got 2 squared, which is 4, and 5 squared, which is 29. And the only thing left to do here is to add the 4 and 20. Oops, excuse me, I jumped ahead of myself, 25. The only thing left to do here is add the 4 and 25 together to get 29. So again, the distance from J to K is the square root of 29, which we already know from the first time we did this problem is about 5.4. About 5.4. Now, you may feel like that's a lot of extra work, but that's probably because it's new. I do want to show you how to load this entire equation into your calculator in one swoop so that you don't have to make multiple steps in the calculator. So I'm going to switch my screen here to the calculator. Slide my paper over so we can see. And I want to load up this giant square root right here. So first things first is I'm going to hit the square root button, Control, then the square root. Now whatever I type in is just going to extend that square root bar further and further. So I'm going to start with a parenthesis and type it in exactly right like we wrote it. -4 minus -6. Close up the square root and put a square on the outside. The squaring button is right here on the left of your calculator. Then a plus sign and a new set of parentheses. 1 minus -4. Close that set of parentheses up. Get your square on the outside. Hit enter. And there is that 5.4 approximation that we've been looking at. About 5.4. So you can type the formula into your calculator in one big swoop. That way you don't have to do this step-by-step work and make small arithmetic errors, and it's flawless. It'll take care of all those double negatives for you. It'll take care of the order of operations. It'll do all of that as long as you load it up correctly. Okay, so what I want us to do next is I want us to go back here to this example we started a moment ago. that we just did. And we've split our space in half so that we can try it again using the distance formula to confirm this result. Okay, so I'm going to help you set it up, and then I'm going to let you solve it however you'd like to. So we're going to start with a giant square root, the distance from L to M. Giant square root. Okay, you got your formula up here to look at if you need to. We start with x2 minus x1. So for this problem, it'll be 4 minus 2 squared plus y2 minus y1. y2 is a negative 1. y1 is 8. So this is what my distance formula would look like. Take a moment. You can either use your calculator or use order of operations. I want you to solve for the distance from L to M. Okay, so I got 9.2 again, which is great, because if I got 9.2 this, or something other than 9.2 this time, then something would have gone terribly wrong since I already got 9.2 last time. So these are a great way to check yourself when you're working, to try both ways. I showed all my work here. I worked it out with PEMDAS. Of course, you could load it all up into your calculator. to get that 9.2. If you're having calculator trouble, come see me and I'll help you out. I want you to pick a method and try this last example. Try it with either the Pythagorean theorem option or try the distance formula, or if you're feeling like you don't know which one you like better yet, try both. Okie dokie. Let's see what we got. I've worked it out with both methods here. I plotted my points. Here in green, let me cover this bottom method up. If I can cover that up a second. Here in green, I've got the Pythagorean theorem set up, okay? I counted my horizontal distance is 15, my vertical distance is 5. Use those as the A and B in the Pythagorean theorem. And then started working through the Pythagorean theorem to solve for this hypotenuse on the triangle, this diagonal distance. So when I got finished, I got the square root of 250, and over here on the side, you'll see where I broke down 250 using a factor tree. And the square root of 250 can be simplified to 5 times the square root of 10. Well, if I want an approximation, I just pop that into my calculator, I get 15.8. So there's option 1, Pythagorean theorem. It's really easy because it's so familiar to us and you might like it a lot. Option 2 is the distance formula down here in pink, okay? I've memorized this distance formula. I've plugged in my x2 and x1. Then I plugged in my y2 and y1. I'm showing you my mental work here in case you like to do the order of operations on paper. I also want to show you my calculator screen where all I did is put everything into my calculator in the distance formula and got out my final answer of 15.8, my approximated value of 15.8. So you have lots of options on how you want to handle distance problems. Anytime you're trying to find the distance between 2 points, you've got 2 different options. 1, the Pythagorean theorem. 2, the distance formula. If you choose the distance formula, you can work your magic on the calculator and it'll do everything for you. Thanks for watching and good luck.